Welcome dear students, we are on the CEC Gurukul lectures. We are in the series of characterization of nanomaterials where we discuss the various methods of the nanomaterial characterization, and in the last two lectures we discussed the X-ray diffraction method. What is the X-ray diffraction method and why we are studying the X-ray diffraction method, that we discussed in the previous lectures. After that we discussed about what are the important components in the X-ray diffraction, and today's lecture we discuss about the various methods of X-ray diffraction. And I am Dr. Sonia Bansal from JC Bose University of Science and Technology, YMCA Faridabad. We discuss today with the XRD methods. What are the methods of X-ray diffraction to get the surface structure of the nanomaterials? So, X-ray diffraction method used to investigate the internal structure and the crystal structure of various solid components. Components maybe we have the single crystal, or we may have the mixture of the crystal. Means crystal may be composed of 2 or 3 materials, and we discuss about its internal structure, and the crystal structure can be formed by using this X-ray diffraction method. Now, what are the methods of X-ray diffraction? There are the 4 methods. Number 1 method is the Liu photographic method. This also divided into 2 parts, transmission method and second is the back reflection method. Both come under the Liu method. Second method is the Bragg's X-ray spectrometer method. This is also the one of the best method of the X-ray diffraction, where the Bragg's law is followed. Basically, Bragg's law follow in all the methods, but this type of X-ray diffraction method where we use the Bragg's X-ray spectrometer. The third method is the rotating crystal method. As the name suggests that the crystal is rotating, then we record its structure. So third method is the rotating crystal method. Fourth method, which is very important and which is commonly used for the X-ray diffraction, is the powder method. As the name suggests, the sample we use in the form of the powder. So there are the 4 methods, in which 2 methods are very important, which used most probably for the characterization of the nanomaterial are Liu photographic method, and second is the powder method. We will discuss one by one in detail. Before discussing this, just these 3 methods, we discuss that Liu method where we find out the orientation of a single crystal, and polychromatic beam is used here, and the fixed angle, the crystal is put at the fixed angle. In the rotating crystal, the angle is variable, and we find out the lattice constant. Single crystal is used for this. Again, the monochromatic beam is used in this rotating crystal. In the Liu method, we use the polychromatic beam which pass from the crystal. And third method is the powder method, where we find out the lattice parameters of the material or the crystal, and the polycrystal powder is used. Polycrystals or the mini crystals, we can say, we use the crystal in the form of the powder. Sample will be in the form of the powder, and the monochromatic beam is also used for the characterization of the material, and the variable angle also used. It means crystal is rotating at a 360-degree angle. So these are the common methods for the characterization of nanomaterial, or to find out its lattice, its structure, or its inner structure, or its defect. We can find it by using the X-ray diffraction method. Before starting the different methods, we discuss the sample preparation for characterization of the material. How we prepare the sample, how we use the sample in the characterization, and in the diffraction pattern we use the 2 type of as we name suggest, the single crystal X-ray diffraction. We use the single crystal for the diffraction pattern. Here we see the single crystal sample is a perfect crystal. All unit cell aligned in a perfect extended pattern. The cross section of this sample is approximately 0.3 mm. So we cut a crystal in such a manner so that we can get the perfect unit cell, and its cross section may be 0.3 mm. The single crystal diffractometer and the associated computer package is used mainly to elucidate the molecular structure of a noble compound. We can use the composition of the mixture or a single crystal in the characterization of the sample. Second method is the second crystal, which we use the powder, which is also known as a polycrystalline. Polycrystalline, it is very important to have a sample with the smooth plane surface. Now here we crush the crystal in the powder form, and this powder is used for the X-ray diffraction, and so we can get the smooth plane surface. It is possible we normally grind the sample down to the particle size of about 0.002 mm to 0.005 mm cross section. It means we are making a mini crystals, and the size of the particle must be of the order of the 0.02 mm to 0.05 mm, and the ideal sample is homogeneous for this, and the crystallites are randomly distributed. The sample is placed in a sample holder. Basically, there is a plate to hold the sample, and the sample is, this powder is pressed with the plate of the sample holder, so that we can have the smooth flat surface and we can easily get the characterized form of the material. Now, next method, which is very important method, as we discussed, there are various methods of the X-ray diffraction. So first method we discuss is the Liu method. As we see on the screen that there are the various components of this Liu method. Left hand side we are having the X-ray tube. In between that we have this slit, so that the X-ray beam can pass at a particular angle to the crystal, which is static, which is not moving. Here we are having a fixed crystal. After the slit we have a crystal, and after the crystal we have the photographic film on which we can get the output. From the X-rays, X-ray pass from the slit and fall upon a crystal, and from the crystal it is diffracted and gives the pattern on the photographic film, which represents the symmetry and geometry of a particular crystal. So this is a Liu method. Basically, Liu explained that the crystal can give the diffraction, as we normally discussed in the optics, that transmission grating is used to get the diffraction pattern, where the transmission grating is in such a manner that the line on the transmission grating is the order of the wavelength of the light fall upon it, and as the light fall upon it, and the pattern of the diffraction we can get by using the diffraction grating. But here the diffraction grating is replaced with the crystal, because the wavelength of the X-ray is very low as compared to the other light sources we use. So to get the diffraction pattern we use the crystal, and the X-ray fall upon this crystal, and the diffraction pattern we can get. So Liu gave this experiment, and he explained the he proved the two points. One is that the crystal can give the X-ray diffraction, and it works as a diffraction grating. Number two, the pattern which we are getting on the photographic plate explain the geometry and symmetry of a particular crystal. So by using this method we can get the diffraction pattern and we can get the geometry and the various parameters of the molecule or of the sample. So this method is very important, and now we discuss that this method is mainly used to determine the orientation of the large single crystal when the radiation is reflected or transmitted through the fixed crystal. As we discussed that the crystal is fixed, light from the X-ray reflected or transmitted through the crystal. The diffracted beam from the array of the spots that lie on the curve of the film. The spots we will get on the photographic plate, and that spots are known as the loose spots, as well as these spots give the symmetry or geometry of the material. The Bragg's angle is fixed for every set of the planes in the crystal. As we know that the Bragg's angle should be followed by the light transmitted from the crystal, so that we can get the diffracted light. Each set of the plane picks out the diffracts and particular wavelength from the white radiation that satisfy the Bragg's law for the value and the theta involvement. Only those radiation will be captured which satisfy the Bragg's law. Bragg's law we discussed in the previous lecture. Now the Liu method divided into two parts. First is the back reflection Liu method, and second is the transmission Liu method. The first is the back reflection Liu method, where we see that the photograph film is in between the X-ray source and the crystal. Means we can get the back reflection through the beam which are deflected in the backward direction, and the pattern is recorded. So in the back reflection method, the film is placed between the X-ray source and the crystal. The beam which are diffracted in the backward direction are recorded. So it is called a back reflection Liu method. Here we see in the diagram the Liu method, where one side of the cone or the Liu reflection is defined by the transmitted beam. The beam is transmitted from the crystal. The film intersects the cone with the diffraction spot generally lying on the hyperbola. We can get the output in the form of this hyperbola. So this is the one of the back reflection Liu method. Next is the transmission Liu method. As the name suggests, light will be transmitted. In the transmission Liu method, the film is placed behind the crystal, and the pattern is recorded when the beam fall upon a crystal and pass from the crystal, which are transmitted through the crystal. So in the transmission Liu method, the film is placed behind the crystal to record the beams which are transmitted through the crystal. Here we see in the diagram, one side of the cone of the Liu reflection is defined by the transmitted beam. The film intersects the cone and the diffraction spot generally lying on the ellipse. In the previous, the back reflection, the pattern is in the form of the hyperbola. Here in the transmission, the pattern is in the spots in the form of the ellipse. So these are the two different Liu methods, back reflection and the Liu and the transmission method. Now what are the advantages of this Liu method? There are the various advantages. It is used for checking the orientation of a single crystal and its quality. So then by using the Liu method, we can find out the quality of a crystal what type of composition we are using in a crystal, and what is the orientation of a crystal, that we can find out by the Liu method. It can be used for analyzing the specimen that are thick and large. All type of specimen we can find out by using the Liu method. What are the limitations of this Liu method? It cannot be used for quantitatively analysis, because the wavelength of the X-ray beam that is causing a specific spot is known. As in this method we are getting a central spot as a Liu spot, a dark spot, and other also spot. So it cannot be used for the quantitative analysis because the wavelength of the X-ray beam that is causing a specific spot is unknown. It requires a large crystal for the analysis. Then the next method is the Bragg's X-ray spectrometer method. As we see on the screen that here, this is the Bragg's X-ray spectrometer. In this X-ray spectrometer we see that A here mentioned in the right hand side, there is a tube, that is a anti-cathode tube which produces the X-rays. B adjustable slit from where the beam is passed on the crystal, where C mentioned the crystal, and E is a full ionization chamber where the crystal is placed, and it is connected with the HT battery so that we can adjust the position of the crystal. And this is the arrangement of the Bragg's X-ray spectrometer. The X-ray fall upon a crystal which is inside the Bragg's X-ray spectrometer, and from here the X-ray fall upon a crystal, and this X-ray pass from the adjustable slit and fall upon a crystal, and from here the pattern can be recorded. Now the one plate of the ionization chamber is connected to the positive terminal of a HT battery. You see it is connected through the D is connected through the HT battery, while the negative terminal is connected to the quadrant electrometer, where we can record the pattern, and here measure the strength of the ionization current, that will explain by using the electrometer. Now, what is the working of this spectrophotometer of this X-ray Bragg's X-ray spectrometer method? Here, the crystal is mounted at angle theta is equal to 0 in the ionization chamber, and it is so adjusted that it can receive the X-rays. X-ray fall upon a crystal which is mounted at a 0 degree angle. The crystal and the ionization chambers are allowed to move in a small step, so that the light comes from the X-ray can be adjusted or at the crystal. The angle through which the chamber is moved is twice the angle through which the chamber is moved is twice the angle through which the crystal is rotating. Here this C is rotating at angle theta, but the chamber is rotating at the 2 theta. The angle through which the chamber is moved is twice, and the angle through which the crystal is rotating. Now X-ray spectrum is obtained by plotting a graph between the ionization current and the glancing angle theta. How the angle theta changes, ionization current changes. That will explain the plot the graph between the ionization current and the glancing angle. Peaks are obtained corresponding to the Bragg's reflection, and that peaks explain the structure of the material. Now different order glancing angles are obtained with known value of dn, and as the value of dn changes from the observed value of theta, lambda can be measured. As the value changes and the d will changes, order changes, then lambda can be found out. Application of Bragg's diffraction meter, X-ray spectrometer, that it is easy to handle. The adjustment of the angle can be done. Theta can be vary On the basis of that, we can find out the ionization current. Thank you very much.